Okay, these are the notes for section 10.8. We have three main concepts we'll be covering in section 10.8: fundamental counting principle, combinations, and permutations. The fundamental counting principle helps us determine the number of different ways that different things can be combined. You have to be careful here, we're talking about different things. If I were to choose, say, 2 students out of my classroom, that would be considered to be the same thing. But if I were to choose 1 student from my room, 1 from Miss Johnson's room, 1 from Miss West's room, that would be 3 different distinct groups that I would be choosing from. So that's when the fundamental counting principle would come into play. Let's start by looking at example 1. For a main dish, you can choose steak or chicken. And whichever main dish you pick, you have your option of 2 sides, rice or potato. And no matter which side you choose, you could have tea, water, or coffee to drink. So to sum that up, we could have steak, rice, and tea, steak, rice, and water, steak, rice, and coffee, steak, baked potato, and tea, steak, baked potato, and water, steak, baked potato, and coffee, or chicken with any of those things, which gives us a total of 3, 6, 9, 12 different possible meals that can be created by choosing 1 main dish, 1 side dish, and 1 drink. Now there are some situations where this would be very lengthy and a very difficult thing to write out. So what we need is a mathematical shortcut, and that's where the fundamental counting principle comes into play. The fundamental counting principle says when we're choosing from among different options, we can simply multiply however many options there are. There are 2 main dishes, there are 2 side dishes, there are 3 drinks. So 2 times 2 times 3 gives us 12. And that's what the fundamental counting principle does for us. So let's look at example 2. A florist is arranging centerpieces that include 1 flower, 1 plant, and 1 vase. The florist has 2 kinds of vases, 3 kinds of plants, and 4 kinds of flowers to choose from. How many different centerpieces are possible? We simply multiply these 3 numbers together. 4 times 3 is 12, times 2 is 24. Okay, next we have a voicemail system password, which is 1 letter followed by a 3-digit number less than 600. How many different voicemail passwords are possible? So the letters A through Z, there are 26 of those. And then 3-digit numbers less than 600. You have to remember that 000 would be included in this group, but not 600. And in this group there are 600 numbers. There are not 599 because we didn't start with 1, we started with 0, so that adds an additional option. So we're choosing from 2 things, 1 letter and 1 number, and that would be 26 times 600, which is equal to 15,600. So that is how many passwords are possible given that setup. Okay, moving on, we have the next concept. We're going to talk about combinations. This is when we're choosing from a group of things, just one group rather than several different groups. So this would be the situation where we are choosing, say, 2 students out of my room, or okay, an example would be like number 4. An ice cream shop allows 2 toppings on a sundae. There are 4 toppings available. We have peanuts, sprinkles, fudge, and chocolate chips. How many different sundaes can be created? One way to find that out is to list them all and eliminate duplicates. So we could have peanuts and sprinkles. We could have peanuts and fudge, peanuts and chocolate chips. We could have sprinkles and peanuts, sprinkles and fudge, sprinkles and chocolate chips. Fudge and peanuts, fudge and sprinkles, fudge and chocolate chips. Or chocolate chips and peanuts, chocolate chips and sprinkles, or chocolate chips and fudge. However, peanuts and sprinkles are the same thing as sprinkles and peanuts, so that's a duplicate. Peanuts and fudge, fudge and peanuts. Peanuts and chocolate chips and peanuts. And in this way we can eliminate all of the duplicates, and we are left with just these 6 options. So there's 6 different Sundays we can create that way. Number 5, an English test contains 5 different essay questions labeled A, B, C, D, and E. You're supposed to choose 2 to answer. How many different ways are there to do this? So I'm going to list these a slightly different way than the last time. You could actually list these without having to eliminate any duplicates. You just simply don't write those to begin with. So if we answer question A, we have 4 different other combinations, or 4 different combinations we can do there. We could answer also B, or C, or D, or E. And that's the only way we can answer 2 questions, one of which is A. So then we can move on to B. We've already listed the B with A, but we haven't listed B with C, or B with D, or B with E. If we include C, we've already listed C with B and C with A, but not D or E. And we haven't listed D with E yet. So this gives us 4, 5, 6, 7, 10 different ways that we can choose 2 of those 5 essay questions to answer. Now, of course, there's a mathematical shortcut for this as well, and that's this formula right here. Sometimes it would take way too long to list all of the options. Number 6 will be a great example of that. I'll show you here in a moment. There is this formula. This is for, the C stands for combination. The N is for how many you have to choose from, and the R is for how many you are choosing. So in this situation, we have 5 questions to choose from. It's a combination, and we're choosing 2. And the formula works like this. The top is n factorial, so this is n, that's r, so it's 5 factorial, and that would be divided by r factorial, so 2 factorial, times n minus r, so 5 minus 2 factorial. Now the factorial means that you take the number that is given and you multiply it by every number all the way down to 1. Now for the purposes of this assignment, I'm going to eliminate times 1 because all that does is give us back the number that we already had. Times 1 is kind of useless to us at this point. So 5 factorial is really 5 times 4 times 3 times 2, then of course times 1, but we'll leave that off. 2 factorial is 2 times 1. 5 minus 2 is 3, and so 3 factorial would be 3 times 2. Now I want you to notice something that's going on here. We have this section here that matches up. That is always going to happen. We have this 3 factorial. That's going to always cancel with the 3 and 2 from here. That's 3 and 2. So those will cancel. And this 4 will partly cancel with that 2. And we're left with simply 5 times 2, which is, hopefully no surprise, 10. Okay, example 6. We have 11 different cereals for sale, and we want to select 4. So N is 11, and R is 4, N and R, which gives us our formula, 11 factorial over 4 factorial times 11 minus 4 factorial. 11 minus 4 is 7, which means we could make this even shorter, and we don't have to write 7, 6, 5, 4, 3, 2 on the top or the bottom because we know those are just immediately going to cancel. We could stop at 8 because the 7, 6, 5, 4, 3, 2 is going to cancel with this here. We do still have to write the 4 factorial, that's 4, 3, 2. But we can use it to partly, or to cancel out with some of the things in the numerator. So let's do that. 4 times 2 is 8. So 4 and 2 will cancel with that 8. And this 3 will partly cancel out that 9. 9 divided by 3 is 3. That leaves us with 11 times 10 times 3. 11 times 3 is 33, times 10 is 330. So our answer here is 330. Okay, at this point, I would like to do that same problem in the calculator. We had 11C4. There is a way to make this calculator do that. This little catalog button opens up a bunch of different options. Usually it starts here at the top of the list. We're on A. If you simply type the N button, that sends you down to the section with the N's. You can Scoot down just a little, and the very next option is NCR. Hopefully that looks familiar. So let's choose that. And we had 11C4, so you simply type those numbers in order with a comma separating them. Here's the comma. 11, 4, and it magically gives us 330. Okay, so the next example says a basketball team has 12 members who can each play any position. How many different ways can the coach choose 5 starting players? So we have 12 to choose from. Order doesn't matter, so it's combination. And we're choosing 5. Plugging those numbers into our formula. Do this quickly. If you'd like to take a moment to pause and fill it in yourself and double check your work, that would be a very good idea. And this is 7. So I'm going to stop when I get to 7. I'm going to have 12, 11, 10, 9, 8. And that will be over 5, 4, 3, 2. 5 times 2 is 10. 4 times 3 is 12. So I'm left with 11 times 9 times 8, which is 792. Okay, and I will just give you the answer here on the next one so you can check your work. Should you choose to work this one out yourself, this ends up being 1,365. At this point, I'm going to stop this video and I will make a part 2 of the notes, which we will use to cover the permutations. So please look for part 2. Thank you.